The function graphed on this coordinate grid shows f of x, the height of a ball dropped in feet after its xth bounce. So how high was the ball in the air before it was dropped?
25 feet.
Right. Turn around and pay attention, please, Nehemiah. Before the ball was ever dropped, it was 25 feet in the air. They want to know on which bounce was the height of the ball at 10 feet. Well, wouldn't you just go to 10, and isn't that the first bounce? So A. That's easy enough. Okay, all you have to do is go to 10 feet. Feet is on the y-axis, so you go to the 10 on the y-axis. Go out, and that's on number 1. Okay, because that's 2, so that's 3, and that's 4. All right, 68. Look at the graph. Which equation represents this graph? When you tried it by yourself, what did you select? Anybody get anything different? Okay, B is correct. The easiest way to figure this out without actually graphing all four and trying to match up the points is to look at where the asymptote is. Where is the asymptote? At 2. Isn't that y equals 2? Well, the only way the asymptote will shift off of y equals 0 is what? If you add or subtract onto the end. And to make it go up 2, you would have to have done this plus 2. Had you had two choices that had a plus 2 on the end, you would have probably had to graph both of those, look at the table, and compare some points on the graph with the points on the calculator. Okay? All right. The next page is where we begin Unit 5. So I'm going to give you about 10 minutes just to try what you can. Okay? Unit 5 goes from page 24 to page 29. So I'm not saying you're going to know how to do them all, but I just want you to try and make educated guesses on the ones that you're not sure of, and then we'll take a break, and then we'll start going over it, okay? Unit 5, problem number 69. Which scatter plot best represents a model of linear growth? B is correct, because first you would look for a model that makes a straight line. Well, B definitely does. Well, B makes a line, but so does C.
That is decline.
Correct. That's what makes it wrong. Not because it's not as tight of a fit as this one, because we're looking for growth. And this is a line that goes up, so it's B. Does that make sense? This is also linear, but it goes down. So it would be linear decay, not linear growth. Number 70. Which scatter plot best represents a model of exponential growth? A is correct. Exponential functions curve and growth goes up. No other ones on there were even exponential though. B was a linear growth. C was linear, but it goes down. And then D, I mean, if you had to draw a best fit line, you could. It would just be weak correlation. Remember when we talked about that in Unit 6? Weak correlation. But it's also linear. Okay, next page. Number 72. Which table represents an exponential function? Correct. And why is that? Okay, because look, 30 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. It's tripling. So it has a growth factor of 3. The rest of them are what kind of function? What are the other three choices? Linear, because look, in A, every time the x goes up by 1, the y goes up by 1. So look, remember, slope is rise over run, so that would be y over x. Your y's are all going up by 1, and your runs are all increasing by 1. So this would be a line with a slope of 1 over 1. B would also be a line. What would its slope be? 22 over 1, or just 22, correct. Because each time your x increases by 1, that would be 1 on the bottom. Your y's are increasing by 22 every time. So your slope would be 22. Where would your y-intercept be for this one? 0, 0. Where would the y-intercept have been for A? 0, 5. Where's the y-intercept for C? And what is its slope? A 8 over 1 or just 8. Because each time the x's go up by 1, the y's are increasing by 8 every time. So that's a slope of 8 over 1 or just 8. The only one that is not linear is this one. It's exponential because it's tripling. Alright, number 72. A table of values is shown for f of x and g of x. Okay, so on the left you have the table for f of x. On the right you have the table for g of x. Their x values in both tables are identical, 0 through 5. But the y values, or f of x and g of x in this case, are a little bit different. Which statement compares the graphs of f of x and g of x over the interval 0, 5? Okay, well when you tried this, what did you guess? Okay, I've heard the right answer out of one of them. What do you, it's D. Okay, but let's talk about why. What I did was, the first thing I noticed was interval. What does interval mean? When they say the word interval, they're telling you to focus on the what? X values. Okay, so, and that's why this 0, 5 is in brackets, not parentheses, because that's not a point. That's not an x comma y. It's an interval, which is an x comma x. So they want to know what goes on from the x value of 0, which would be right here in this table and right here in this table, and then the x value of 5, which would be those points. Well, in the f of x, it starts out 0, 0, and then it goes to 5, 25. G of x, it starts out 0, negative 2, so smaller, but then it goes from 5 up to 29, so the graph of f of x always exceeds, is f of x's y values always bigger than g of x? No. The graph of g of x always exceeds. Are the g of x values always bigger than the f of x values? No. Like right here, until you get to this one, these values are actually smaller, right? So that one's out. The graph of g of x exceeds the graph of f of x over the interval 0 to 4. By the time it made it to the 4s, was the g of x bigger? No, at that point the f of x was still bigger. But then the graph of f of x finally exceeds the graph of g of x. Oh no, the graph of f of x exceeds the graph of g of x over the interval 0 to 4. That is true. Because really, we don't care about the 5, do we? None of, like, we already ruled out those and they didn't work. So we need to focus in on the interval 0, 4. Well, this one says g of x exceeds it from 0 to 4. So we're not worried about those. We're worried about those coordinates from 0 to 4. Well, f of x is the bigger one at that point, right? Than g of x. So you're looking for this one. The graph of f of x exceeds the graph of g of x over the interval 0 to 4. They intersect somewhere between 4 and 5, and then g of x starts to exceed. Does that make sense? I know that's a lot to kind of take in. You just got to take one statement at a time and think about it. Okay? All right, next page. Which statement is true about the graphs of exponential functions? Okay, y'all think the graphs of exponential functions always exceed the graph of linear and quadratic? It is C. Okay, what I did was I graphed a linear function, which is, remember, y equals mx plus b, so couldn't that just be y equals x? Because your m would be 1, your x, and then your b would be 0. Then I graphed a quadratic function, which would just be y equals what? What's the parent function for quadratics? What kind of graph is a quadratic? Like, what kind of shape will it make? A parabola, a U shape, and what is the parent function for it? X squared. And then exponential, remember, it's when x is the exponent. So you can just pick whatever base you want for the base and then raise it to the x. And now look when we graph them, what happens. There's linear, there's quadratic, there's exponential. So at first, maybe the exponential is not the largest. But then won't it eventually go faster and faster? It'll rise faster than the others, so it will eventually exceed the graphs of the linear and the quadratic. Okay, because exponential, it shoots up faster and faster than the line and the parabola do. So it's C. Alright, number 74. Which statement best describes the comparison of the function values for f of x and g of x? Okay, so you got f of x in this column, g of x in this column. A, the values of f of x will always exceed the values of g of x. I mean, they do right here, but does that mean always? This is what I did. I continued my table. Over here I did 5, 6, 7, 8. Okay, those are still x's. And then I continued my f of x's, and then I continued my g of x's. Well, I looked at the patterns. What pattern do we see in f of x? It's going up by 2, so the next number would be 10, then, okay. What's going on with the g of x's? Well, first they go up by 1, then they go up by, -6 to -1 is 5. -1 to 6 is, so what's the pattern? Each time they're going up by 2 more than the previous. So the next time, aren't they going to go up by 9? So what's 6 plus 9? And then the next time, won't they go up by 11? So what's 15 plus 11? And then the next time they would go up by 13. So what's 26 plus 13? And then the next time they go up by 15. So that plus 15 is 54. Now that we have more to look at, now let's look at them. The values of f of x always exceed? No, you can see when we continued that f of x values are not exceeding anymore, so that one's out. The values of g of x always exceed? No, because over here they didn't. They were smaller. The values of f of x exceed the values of g of x over the interval 0 to 5. So from 0 to 5, are the f of x ones bigger than the g of x ones? Look at it again. Okay, look. It says over the interval 0 to 5. That means from the x value of 0 and the x value 5, are f of x values always bigger than g of x? They are until you get to what? 5. At 5, they get bigger. The g of x get bigger than the f of x. So D, the values of g of x begin to exceed the values of f of x within the interval 4 to 5. Look, at 4, f of x was bigger. But at 5, g of x was bigger. Well, isn't that what that statement says? Between 4 and 5 is when g of x begins to get bigger than f of x. So that one's right. Does everybody understand? You can't just answer that problem in 30 seconds. You have to think through it. Alright, number 75. If the parent function is f of x equals mx plus b, what is the value of the parameter m for the line passing through the points -2, 7 and 4, 3? Well, the first thing you kind of got to figure out is, what is this question asking for? What is this question wanting to know? The slope. They just word it funny. They say the value of the parameter m, but we all know what m is. It's slope. And then they give us 2 points. So isn't that our x1, y1, and x2, y2? And then the slope formula is on your formula sheet, right? Well, we won't be in here, and plus if we were to be covered up that day. Okay, but the slope formula is the very first formula on your formula sheet. So you will have it. It'll just be a drop down on the computer. You'll be able to click it and it'll drop down the formulas. Okay? So the formula for slope is m equals y2 minus y1 over x2 minus x1. So what goes in the y2 place? Minus what goes in the y1 over what goes in the x2? 4, and then minus what goes in the x1. Okay, well if I set a -2 right here, what's this going to become? +2. So 3 minus 7 is, and 4 plus 2 is, do you see that answer over here? Well, you don't see that exact answer because what did they do? They reduced it to -2/3, so it's D. Okay? Alright, number 76. Well, you didn't have to do number 76. They told you the answer. We forgot to white it out. Okay, but we'll talk about it. Consider this function for cell duplication. The cells duplicate every minute. Describe the parameters of this function. So they were just trying to ask you if you knew what the 75 represented and what the 2 represented. Well, the 75 is always your start value. Whatever's out front in an exponential function is always your starting value. So they started with 75 cells. And then the cells were doubling because your growth factor is 2. So that's what they wanted you to see. Just remember, in an exponential function, the first number in the A place is always your starting value. The number in the B place is your growth or decay factor, and then X is time. Alright, number 77. Look at the graph of the functions h of x and p of x. Okay, well, first of all, what kind of graph is h of x? No. A parabola. Okay? H of x equals x squared, and it's a parabola. Okay? P of x is what kind of function? Exponential, and it's an exponential growth. The reason we know it's exponential is because x is the exponent. Okay, they want to know which transformations would you have to do to translate each function so that they would both pass through the point 0, 1. So they're wanting to know what you would need to do to these things to get them to both hit the point 0, 1. Well, to get the parabola to come up and hit that, what would you have to do? Guys, think about it. If you want this parabola that currently sits at 0, 0 to come up and sit at 0, 1, what would you have to do to the parabola? Add 1 if you want it to come up 1. Okay, so look down here. Wouldn't we want the h of x function to go up 1? And then to get the p of x function to come down 1 unit, wouldn't we want it to come down 1? So it's d. But does that make sense now? That's pretty easy if you just think about it. What would a do to it? H of x minus 1 in parentheses. What kind of shift would that be? Right 1. What would B shift be? Left 1. And what would C shift be? Down 1. Over here for the P functions, what would this one be? Left 1, up 1, and down 1. Okay? Alright, number 78. Nehemiah, wake up. Look at the functions f of x and g of x. I'm going to write them again because they're kind of hard to read. F of x equals x squared, so that's a what? Guys, f of x equals x squared is a what? A parabola. It's a quadratic function. G of x is a what? That looks like y equals mx plus b, Bradley? Shh. This is a exponential because x is the exponent. Is it an exponential growth or decay? Growth, because your b is a 2. If your b is bigger than 1, it's a growth. If your b is less than 1, it's a decay. Now, they want to know which transformation of f of x makes f of x less than g of x. So what I would do is I would graph them both first. Okay, so f of x equals x squared is my first one. And then my second one is 2 to the x power plus 3. And remember, f of x is the parabola, so on mine it's the blue. They want to know what will make f of x less than g of x. So what can we do to the parabola so that every point on it is less than the exponential curve? Okay, let me say that again. They want to know what you would need to do to make f of x, which is the parabola, less than g of x. So we want every single point on the parabola to be lower than the exponential curve. What could cause that? Well, think about it though. Even if you shifted it down, isn't it still going to open up and there will be points that go bigger than the curve? What else could you do to that parabola so that every point on it is sitting lower than the curve? Well, even if you shrunk it and you made it wider, it's still going to go up, so you're still going to have points that get higher than the curve. Flip it over. Think about it. If we took this parabola and flipped it upside down, wouldn't every point then be lower than the curve? So which one is that? No. No. B. Let me show you. If you take the whole thing and make it negative, y equals, and make the whole thing negative x squared, it flips it, and now see how every point is lower? So it would be A. I mean, not A, sorry, B. Okay, number 79. 80 to 83. We're almost done. We got to go from 79 to 83. Until our next break. All right, number 79. Which function is modeled in this table? Okay, well, first of all, you got to figure out the pattern in the table. It does. Multiplies by 5 every time. So when you have a function that's multiplying by the same number every time, is that linear or exponential? Exponential. Okay? To be linear, it would have to add or subtract by the same thing every time. So I went ahead and crossed out A and B because those are both in y equals mx plus b form, which is linear. Now you just have to decide, because C and D are both exponential functions, which one is right. How would you figure this out? Right. Like, look, if I start with C, which is 8 to the x power, and I plug in 1 into the x, what's 8 to the first power? So it worked for that one. But now let's try the next one. If I replace that x with my next x value of 2, is 8 squared 40? No. So now let's look at D, just to make sure we didn't make a mistake somewhere else. 8 fifths times 5 to the x power. If I plug in my first x value of 1, type that in and see what you get. Just type it in. No, I'm not going to take this test next week. You are. I'm just going to stare at you while you take it.
What day are we taking it?
Tuesday. Okay, so it gives you A. Now retype it in, but in the x place, put a 2, which is the next x value. So did you actually try it, or are you just assuming because that's the next y value? But what if we've made a mistake somewhere else in this problem? Okay, you get 40. And if you typed in 3, what do you think you would get? 200. If you typed in 4, you would get 1,000. So does everybody know how to plug in things into a function? Okay, number 80. What'd y'all get for number 80? C is correct. You shouldn't have to guess on a problem that easy. We've already done several of these too in this packet. If f of 12 equals 4 times 12 minus 20, what function gives f of x? So aren't they basically telling you, instead of f of 12, make it f of x, which means replace this 12 with an x, and you get 4x minus 20. There it is. That's easy. We've seen several of those. Which function has a range of f of x is less than or equal to 3/4? Okay, well, what is f of x the same as? Y. Okay, so we're looking for which one of these would have a y value. Every single y value on it would be less than or equal to 3/4. What's the easiest way to figure this out? Graph them all and figure out which one of them's y values are all below 3/4. So start with A. Y equals 3/4 x. Pay attention, we're almost done. Focus. Plus 5. Is every single y value on that graph below 3/4 on the y-axis? No, most of them aren't. Here's 3/4 on the y-axis, so every single one of these from here up has a value higher than 3/4, so it's not A. Now let's try B. Negative x squared plus 3/4. Is every single point on that graph below 3/4 on the y-axis? So it's B. That's all you have to do. All right, next page. Last page before our next break. So focus, 2 problems. Shh. A sample of 1,000 bacteria becomes infected with a virus. Each day, 1/4 of the bacteria sample dies due to the virus. A biologist studying the bacteria models the population of bacteria with the function P of T equals 1,000 times 0.75 to the T power. See, the reason 0.75 is your decay factor is because you're losing 1/4 a day. So the next day you only have 75% of what you had the day before. Does that make sense? Okay, they want to know what is the range. Okay, well when you hear the word range, what do you think of? Y values. But in this particular function, we don't see a Y. What's the same as Y over here? P of T. Isn't P of T where Y normally is and T is where X normally is? So P of T is your Y's. So what can that help you do with your choices? Eliminate A and B, because A and B are both talking about T, which would be domain. That would be X values. P of T is what we're looking at because we're looking for Y values, range. So any real number or whole number? Think about in context of this problem. Whole number. These are bacteria. Okay, so it's whole numbers because they're bacteria. You're not going to split them, right? All right, number 83. The graph shows the height, y, in meters of a rocket above sea level in terms of time, t, in seconds since it was launched. The rocket landed at sea level. Okay, so let's see if you can understand how to read this graph. How high did the rocket get? I'd say like right above 300 feet. And how long did it take it to reach that height? 5 seconds. Okay, if you follow it down to the time, that's 5 seconds. They want to know, what does the x-intercept represent in this situation? Well, where's the x-intercept? Right, 10 point something, right? So in that 10 point something seconds, okay, maybe like 10.75 seconds because it's closer to 11. So A, the height, does the x-intercept, that 10 point something seconds, represents the height from where the rocket was launched? No. First of all, we already know it's seconds because it's on the x-axis. So get rid of anything that says height. The time it took the rocket to return to the ground. Yes, that's right. That's how long. Well, think about it. It went to its highest, and then it starts falling, and it hit the ground at 10 point something seconds. So it's the time it took for the rocket to return to the ground. Does that make sense? Okay, so I want you to give me some numbers. We got to create a list of data. So tell me a number.
6. I said it first.
Okay? Okay?
4,500.
This is just going to make more work for y'all.
Take off that 500.
Yeah, let's try to keep them below 100.
32.
Nehemiah, I'm already teaching.
32.
Trey, Brandon, go to your seat, and Trey, go to your seat. That's not going to work.
How long are you talking?
I know, but still, you can go back during break. Trey, go to your seat.
5. Oh, crap.
I don't know. Just maybe 4.
2, 3, 4.
It's okay.
4. We had a little bit more. Always just over.
8.
Okay. Shh. Now what we're going to do is we're going to go over the measures of central tendency first. The measures of central tendency are mean, median, mode, and range. Okay, how do you calculate mean of a data set? Right, you add them all up and divide by how many there are. So go ahead and do that. Everybody needs to do it, not just 1 or 2 people. Add them up, divide by how many there are. So the sum of all of those numbers is 251. Then you divide it by how many there are. So what do you get when you divide that by 14? 17.928. So we'll just round it to the tenths place, which would be 17.9. So that's your mean. What's another word for mean? Average. Okay, median. How do you find the median?
You got them in order.
Right. It's the middle, but once you put them in order. So I'm going to rewrite them down here in order. So what's the lowest number?
One, two, three, 4, 5, 6, 7.
Okay, and this is what I always suggest. Anytime you're reordering, mark them off. 1, 2, 3, 4 has been used, 5's been used, and 2 6's have been used. Okay, is there a 7, 8, or 9? No, so the next number is 10. Okay, then 20.
20, 32, 95.
So we use 20, we use 32, we use 33, and we use 95. Okay, now that they're in order, you find the middle. Well, what problem do we have here finding the middle? They're even. So what do you have to do?
Add both of them up.
Right, you find the two numbers that split the middle first. So 1, 2, 3, 4, 5, 6, 7 this way. 1, 2, 3, 4, 5, 6, 7 this way. What's the average of 6 and 10? 8. Okay, because the average of 6 and 10 is 8. So that's your median. If you'd have had exactly one middle number, it would have been median. But anytime two split the middle, you have to average them. Okay, what's the mode?
Most common.
Okay, so what's the most common? Correct. You have two modes here. 6 repeats twice, but so does 17. So we have two modes. What's the range? How do we calculate range? Correct.
95 minus
Right, you do the maximum number of the data minus the minimum number. 95 minus 1 is 94. Okay, so those are called the measures of central tendency, mean, median, mode, and range. We're also going to review how to create a box and whisker plot with this data. Now, to create a box and whisker plot, you have to have what we call the 5-number summary. Please try to focus. No, those are the measures of central tendency. The 5-number summary is the minimum and maximum. Correct. And the 3 quartiles. See how that's 5 things? That's what makes up the 5-number summary. Well, we kind of already know the min and max. We already talked about it to find the range. What's the minimum number? 1. What's the maximum number? Okay, sometimes the minimum is also called the lower extreme, and the maximum would be called the upper extreme. What else could we call that 95 in this list of data? A what? He's on the right track. Outlier. Okay, because it's far from the rest of the data. Okay, a data item that is way far away from the rest of the data is known as an outlier. So 95 would be an outlier. Now, Q2 is the exact same thing as median. Well, we already know the median is 8, so that's Q2. Q1 is the median or middle number of the lower half. The lower half would go from 1 all the way to 6. The upper half would go from 10 all the way to 95. Okay, look, the median is the middle. The lower half is everything to the left of that. The upper half is everything to the right of that. So what number is in the middle of the lower half?
4.
Exactly in the middle? 1, 2, 3, 4. 1, 2, 3, 4. So Q1 is 4. What is the median of the upper half? 1, 2, 3, 4. 1, 2, 3, 4. So 20. Now, to put this on a box and whisker plot, you would need a number line. And then you have to think about how to number that number line. Because we've got to get all the way from what to what? 1 to 95. So yeah, maybe we'll just go by 10. So starting at 0, and then we'll just go all the way to 100 by 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so this is 10, 20, 30, 40. Okay, to construct the box and whisker plot, the box is created by your quartiles. So at 4, we'll draw a line. Okay, that's 0, that's 10. So 5 will be about there, so 4 would be about there. Q2 is 8, so it'll still be back here. And then Q3 is 20. Okay, so there's your box. Okay, your box is constructed by your quartiles. You draw a line for each of the quartile numbers, and then you just top it off, put a bottom and close it up. Your whiskers go to your min and max. So one would be right here. So there's a whisker that goes to there, and then another whisker would go all the way to 95. Okay, so that's the box and whisker plot for this data. Y'all kind of remember this now?
No.
Okay, let me show you something else in the calculator. See this button right here that says Stat? Right below Delete. Okay, click Stat. Pay attention, this will help you a lot on your EOC if you remember how to do it. Hit Stat, and then hit Edit. It's already on Edit, so all you have to do is hit Enter. Now, there's probably going to be some data already in there. Let me show you how to clear it. Let me show you how to clear it. Go up to where the list is highlighted and hit Clear, and when you go back down, it'll all be gone. Okay, so whatever lists have data in them, clear them. Go up till you highlight the L whatever, hit Clear, and then go back down. Now type in our data into L1. So type it in. You can type it in either order. It doesn't matter. I'll just type them in since we already put them in order. I'll type them in order. 5, then 6, 6. You type in yours. I'll type in mine. And then do not type in 8 because that wasn't part of our data. Remember. So 10, 17, 17. 20, 32, 33. And then after I type in my data, I would look up here. It says L1, which means list 1, data item 15. Well, do we have a 15th item to type in? No. So that means there's been 14 numbers typed in because it's waiting on the 15th number, right, Nehemiah? You're going to want to remember how to do this next week. Okay, nobody will be able to show you next week. Okay, now that your list is in, you're going to go back to Stat and over to Calc. This is one variable statistic, so just hit Enter. Now, right here, pay attention because we've been doing this a lot in Algebra 2. You should only have list L1. If there's something right here beside frequency list, clear it out. So just go to it and hit Delete. So all you should have is your list is an L1. Now go down and click Calculate, and you should see this pop up on your screen if you followed all my directions. What did we get for our mean of this data? 17.9. Look, X bar, which is the notation for mean, 17.9. So X bar is mean. What did we get for our median? 8. Median equals 8. The calculator does not tell you mode. You just still have to figure that on your own. And it doesn't say range equals, but it will tell you the max is 95, the min is 1, so you just have to subtract them. It also tells you your quartile 1, quartile 2, quartile 3, 4, 8, and 20. And isn't that what we got? And isn't that a lot faster to do that in the calculator than to do it all by hand? Okay, so let's quickly go over the directions again. You go to Stat, Edit to type in your list, put all of your list in L1. Then you go back to Stat, Calc, one variable, make sure this says List L1, and then hit Calculate. And then there's all the information you need. Okay, so for the next 15 minutes, you're going to be working on Unit 6 material, which is page 30 to the end of the packet, page 34. I want you to try your best, and then we'll go over it. Go. Unit 6. This is page 30. This table shows the average low temperature in Fahrenheit recorded in Macon, Georgia and Charlotte, North Carolina over a 6-day period. What conclusion can be drawn from the data? What did y'all get? C is correct. Okay, but let's talk about why. The first thing I did was I read through each thing. I said, okay, A talks about the interquartile range. But to find IQR, that takes quite a bit of work, right? Because you first have to list the data in order, then you have to find their 3 quartiles, then you have to subtract. How do you find interquartile range anyway?
Subtract Q1 from
Right. Interquartile range is Q3 minus Q1, which that's easy, but listing them in order and finding the Q1, Q2, and Q3, or even putting them in the calculator can take some time, right? So even though you might know how to do that, that could take some time. So let's skip it for a second. B says the lower quartile.
That's fine.
Well, that's Q1, right? Well, we would still need to do some work to find Q1. C talks about the mean and the median. Can't you quickly find the mean and the median? Okay, really, you could quickly find the data for all of these if you just put them in the calculator. If you go to Stat, Edit, in L1, I'll put the data for the first city, which is Macon. So 71, 72, what's next? Call them out for me. Whoa, whoa, whoa. I didn't say the second. So that's all of the data for Macon. So there's 6 of them. Now I'm going to go over to L2 and I'm going to find the data for, or I'm going to put in the data for Charlotte. So 69. I can't type that fast. 68. Okay, so those are the temperatures in Fahrenheit for Charlotte. Now that the data's in there, Nehemiah, remind us what we go to next. Stat. Calc. One variable. And look, right now though, it says list L1, which means we're calculating the data for Macon. So we go down to calculate. And there's all the information you need to know for Macon. What is Macon's average temperature? Right, mean is X bar, so the mean of Macon's temperature is 70.3. So I'm just going to write Macon right here and put the mean is 70.3. It also asks about the median. What does it say the median is for Macon? 71. Okay, and then I'm going to do the same thing for Charlotte's. But Charlotte's list is an L2, so watch how I'm going to do that. I'm going to go to Stat, Calc, one variable. Right, how do you change it? No, it's L sub 2. So you would have to, well, first delete it, and then look right here above the regular 2, so how it says L2. Second L2, and then calculate. And that'll be the second list, which is Charlotte's data. And what is its mean? 70.2. And what's its median? 70. Okay, so its mean is 70.2, its median is 70, and statement C says the mean and median temperature in Macon were higher than the mean and median in Charlotte. Is that true? Yes, barely, but they're a little bit higher, so C is correct. And then say that that didn't work out. At least now you've already got all the data in your calculator to figure out this other stuff and narrow it down. Okay, number 85. A school was having a coat drive for a local shelter. A teacher determined the median number of coats collected per class and the interquartile range of the number of coats collected per class for freshmen and sophomores. The freshmen collected a median number of coats per class of 10. So doesn't that mean for freshmen, their Q2 value is 10? And then the IQR was 6. And doesn't that mean from Q1 to Q3 would be 6 units? Okay, but that's kind of tricky because, I mean, that could be 8 to 14. It could be 6 to 12. But what people don't realize sometimes is sometimes your Q1 and Q2 could match. Yes, depending on your data, your Q1 and your Q2 could be the same. So if Q1 is also 10 and the interquartile range is 6, what could Q3 go up to at the highest? 16. Okay, so now let's do that same reasoning for sophomores. If they collected a median number, so Q2 of 10 as well, but their interquartile range was 4, what's the highest their Q3 could be? And so to fit all of those in there, it'd have to go from what to what? Which is C. That's how you do that one. Alright, number 86. A reading teacher recorded the number of pages read in an hour by each of her students, and the numbers are shown below. For this data, which summary statistic is not correct? Okay, well, is the minimum 39? Yes. That's the lowest number, but we're looking for not correct, so A's out. Hold on.
Shut up, guys.
You're slowing us down. Let's skip lower quartile for a second, because that's not something that's simple to find, like minimum was. Median is also not just something you can just find right away, but maximum is. It's the maximum 51. Okay, but we're looking for not correct, so D's out. So it's either B or C. So aren't we going to have to know the quartiles? How do you find the quartiles? Put them in order. Well, we already know 39 is the lowest, 51 is the highest, so let's list them in between. Hold on, I like to cross my eyes again. 43, 44, 44. 49's next, and then 49, and then 50, and 51. Listen, if you do not cross out as you go like I do, you better, after you relist them, count them, and make sure it's the same amount that was up there. Okay? If you do not cross them out as you go, you better recount after you've relisted to make sure you've listed them all. Okay, so now, what do you have to find first? The median. Q2 has to be found first. Well, how many numbers are there? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So with 9 numbers, is there going to be an exact middle? Yes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's Q2. So look, it says the median is 45. Well, that's true. So the answer must be B. And then look, lower quartile is 44. Isn't this the lower half? Which this is a mistake too, because what should the lower quartile really be? 43.0, but we're looking for not correct. Okay, so B is not correct. Alright, next page. A science teacher recorded the pulse of each of the students in her class after the students had climbed a set of stairs. She displayed the results by class using the box plot shown. Okay, so she has 4 classes, and those are the box plots for each of them. Which class generally had the highest pulse after climbing the stairs? Class 3. Okay, because more of their data is to the right than any other class. Okay, they had higher pulse rates than any other class. Alright, let's talk about something else just in case you see it on the EOC. Which class has the greatest variability? 2 or 4 kind of match up. Variability is spread. You see how spread out the data is in class 2 and class 4? Yeah, but that's just a whisker. That could be going to one kid. Let's look at the box. Which box has more spread? 2 appears to. So really, class 2 might have a teeny bit more variability than class 4, but they're almost the same. Okay, variability is spread, like how spread out the data is. Number 88. Peter went bowling Monday to Friday 2 weeks in a row. He only bowled 1 game each time that he went, and he kept track of his scores below. What is the best explanation for why Peter's week 2 mean score was lower than his week 1 mean score? B is correct. He had a low score in week 2, which would have brought his average down. Does that make sense?
Yes.
I'm sorry, but it'll be wrong in that case.
But then they mark it wrong and then...
Alright, 89. A computer's grading it. The histogram shows the frequency distribution of duration times for 107 consecutive eruptions of the Old Faithful geyser. The duration of an eruption is the length of time in minutes from the beginning of spewing until the water stops. What is the best description for this distribution? This is actually called skewed left. Okay, yeah. If more of the data is to the right, it's skewed left because there's a tail to the left.
Alright.
Okay, let me say that again. it's opposite of what your common sense would say. Yeah, everybody would be like, oh, that's skewed right. But this is actually skewed left. If all the data had been over here and there'd have been a tail to this side, it would have been skewed right. Okay, so this is not correct. If anything, the data is skewed to the left. The correct answer is bimodal. Because look, these two are the same, these two are the same, these two are the same, and then all four of those are the same, so there are many modes in this data. It's not uniform. Uniform would be like a bell curve. Like if all this data were in the middle and then it got smaller on each side, that would be uniform. Okay? And then multiple outliers would mean like there's a lot of stuff far from the data, but there's really not. Okay? Alright, number 90. Which graph most clearly displays a set? Can I read it? We talked about this. You're slowing us down by not waiting till I ask the question. Brandon. Which graph most clearly displays a set of data for which a quadratic function is the model of best fit? What's a quadratic function? A U, a parabola. So that would be A. Alright, next page. We're skipping number 91 because it doesn't even make sense. It doesn't work out with a good answer. Okay, number 92. This graph plots the number of wins in the 2006 and 2007 season for a sample of professional football teams. Okay, now you got to read this. The x-axis is wins in the 2006 season. The y-axis is wins in the 2007 season. Based on the regression model, what is the predicted number of 2007 wins for a team that won 5 games in 2006? What did y'all guess?
I got C.
8. It's 8. C. Let's talk about why. If you go to 2006, pay attention, we're almost done. You just got to focus a few more minutes. If we go to 2006, which is the x-axis, and we go over to 5 games won, which would be right here, and then you go up, the closest thing to that are these 2 points, correct? Which are 8 and 10 on the y-axis. Well, I don't see a 10, so you go with 8. Okay? Alright, next page, and last page. Shh, I told y'all to stop doing that, it's annoying. Which best describes the correlation of the 2 variables shown in the scatter plot? Well, it's definitely negative because it's going down. And I would have called it weak, but the answer key said strong. I guess to be weak, you would want to look for something that maybe had some outliers, you know. Hopefully on the test it'll be a little more obvious because, yeah, that's a little bit, it's not super strong. But there were no, like, things far from the data. Okay, number 94. Which of these statements is an example of causation? Let me read them. When the weather becomes warmer, more meat is purchased at the supermarket. Does the weather becoming warmer cause people to go buy meat at the supermarket? No. There may be a correlation because people have cookouts, so maybe more meat is purchased. But that it does not directly cause them to buy the meat. Okay, B. More people go to the mall when students go back to school. That doesn't even make sense at all. It would be the opposite, really. Shh, turn around. The greater the number of new TV shows, the fewer number of moviegoers. No, I mean, there's correlation, but we're looking for causation. Does more TV shows on TV cause you to not go to the movies? No. After operating costs are paid at a toy shop, and as more toys are sold, more money is made. Yes, you will definitely, as you sell more toys, that will definitely cause more money to be made. Okay, so it's D. Alright, last question. Shh. To rent a carpet cleaner at the hardware store, there is a set fee and an hourly rate. The rental cost C can be determined using this equation when the carpet cleaner is rented for H hours. Which of these is the hourly rate? How much are you going to pay per hour? Okay, look. Let me look, the cost will equal a set fee, which doesn't change, so the set fee would be 25, you're only gonna pay it once, plus $3 an hour. So the hourly rate is $3.